Every single software architecture, no matter how perfectly designed it seems on paper, has hidden dangers lurking beneath the surface. We're talking about weak points, blind spots, all the little assumptions that can snowball into total disasters down the line. Today, we're going to learn how to find them before they find you.
Just for a second, think about the system you work on every day. What's that one thing that kind of keeps you up at night? Is it that single point of failure you've been meaning to fix? A security vulnerability you suspect is there? Or maybe a performance bottleneck that you just know is coming? These are the exact ticking time bombs we need to defuse.
All right, so the very first step is just admitting it. Risks exist in every system. It's a fact of life. But, just having a gut feeling that something's wrong isn't really enough. We've got to move past those subjective hunches and get into a structured, objective way of actually analyzing and talking about these risks.
I mean, we've all been in those meetings, right? Where people are just tossing around terms like low, medium, or high risk. But what does medium even mean? Seriously, my medium could be your absolute worst-case scenario. This kind of vague language just leads to confusion, arguments, and, you guessed it, nothing gets done. We need a common language.
Okay, so let's dive into the tool that gives us that common language. It's called the risk matrix, and it's this brilliantly simple framework that's designed to just cut through all that subjectivity and give us a real concrete number we can all talk about.
So the matrix works on just two key dimensions. It's super simple. First, you ask, what's the overall impact if this risk actually happens? Are we talking about a minor feature going down or the whole system crashing and burning? We rate that on a scale from 1 for low impact to 3 for high. Then, the second question, what's the likelihood of this thing actually happening? Is it something that could pop up every day, or is it a once-in-a-decade kind of event? And again, we rate that from 1 for low to 3 for high.
Now, here's where it gets really interesting how these two things come together. We just multiply the impact score by the likelihood score. That's it. And that gives us a final risk score, somewhere from 1 to 9. As you can see here, scores of 1 and 2 are green, that's low risk. 3 and 4 are yellow for medium risk. And anything 6 or higher, well, that's red. That's a high-risk area we have to deal with, right now.
Let's make this real for a second. Imagine you've got this one big central database. If it goes down, the impact is a 3, no question. It's catastrophic for the whole app. But here's the thing, it's set up in a super resilient clustered configuration. So the likelihood of it actually failing is really, really low. Let's call it a 1. Now here's the crucial part. We multiply those. 3 times 1 gives us a score of 3. So it's a medium, yellow risk. Yeah, it's important, for sure, but it might not be the absolute number one thing you need to fix this very second. So we've got this awesome tool for scoring individual risks. Now let's see how we can build on that to create something even more powerful. Basically, a high-level report card for your entire architecture. This is what a risk assessment looks like. Think of it like a regular health checkup for your system. We take all the key things we care about, scalability, security, data integrity, and we map them against the major parts of our application. And then each little cell in this table gets its own risk score, calculated using that matrix we just talked about. A table like this immediately makes the problems jump right out at you. I mean, look at that top left cell. Data integrity for customer registration has a score of 9. That's a code red alert. It's high impact and high likelihood. This report just screams at us that this is the most critical area to fix in the whole system. It's way, way more urgent than, say, that medium security risk over in the catalog checkout. Now, a risk assessment like this is fantastic, but let's be honest, it's only as good as the person who actually creates it. What if they have blind spots? And they always do. This is where we have to bring in the whole team and really harness the power of collaboration. The reality is, modern systems are just way too complex for any single person to understand completely. The architect, sure, they know the high-level design, but a senior developer, they know the messy, ugly details of some specific integration. And a tech lead might have experience with a third-party service that no one else has even touched. To get the full picture, you absolutely need all those different perspectives in the room. So this collaborative process has a name. It's called risk storming, and it follows 3 really clear steps. First, identification. And here's the key. Everyone works individually at first to brainstorm risks and score them. This is so important because it prevents groupthink. Next is consensus. Now the team comes together, shares what they found, and debates, sometimes pretty passionately, until they can all agree on the scores. And finally, mitigation. This is the most important part, where as a team, you figure out how to actually fix the biggest risks you found. And this is exactly why it works so well. The book gives this perfect example of a time when one person in the session rated a component as a 9, a huge risk, while literally everyone else completely missed it. Why? Because that one person had direct, painful, real-world experience with that specific component failing under load. That one piece of knowledge, which only came out because they were all in the room together, probably saved the project from a guaranteed disaster in production.
To really see the power of this, let's walk through a quick case study. It's for a nurse diagnostics system. And this is a high-stakes application, right? It needs to support 250 nurses and hundreds of thousands of patients, all at the same time. Things like availability, elasticity, security, they're completely non-negotiable.
And wow, this just shows you the transformation perfectly. On the left, you've got the initial architecture, and honestly, it looks pretty good on paper. But on the right, that's the architecture after the team did a risk storming session. The difference is just night and day. Let's dig into what they actually found. So the team's collective brainpower uncovered these massive risks. They realized that the single central database was a huge availability risk, so they split it into two. They saw a major elasticity bottleneck and added message queues to handle sudden bursts of traffic. And maybe most importantly, they spotted a giant security hole where regular users could have potentially accessed sensitive medical records. So they fixed that by creating completely separate, isolated API gateways for the different user types.
Okay, so these tools and techniques are obviously incredibly powerful, but their real value, it comes when they become a part of your team's DNA, your culture. This isn't about doing a one-time audit. It's about a continuous, ongoing shift in how you think about building software. So let's wrap this up with the key takeaways. First, risk analysis is a team sport. Period. You need everyone's perspective to see the whole board. Second, use objective tools like the risk matrix to have productive conversations based on actual data, not just feelings. And finally, remember the ultimate goal here isn't just to find problems. It's to build a proactive culture of continuous improvement, where this kind of analysis is just something you do all the time. So I'll leave you with this final thought. Go back to that ticking time bomb, the one you thought about at the beginning. Now that you have these tools, what's really stopping you from getting your team in a room to analyze it objectively? What is that one risk that you can and absolutely should risk storm next week?